React hooks. React hooks uses the special features of the React framework by calling special hook methods in the React component. We can build any static or dynamic components by writing those powerful hook functions. Generally, UI components become dynamic and they need to change the state of their data very frequently. They need to reactive lifecycle events, sometimes need to access the DOM many times. But before the hook, developers used React class components to serve the purpose. Next, when React introduced hooks, by which developers can serve those features in a more organized way. React has 10 built-in hooks. And in this video, I will discuss all of the hook features. In addition, you will create your own hook functions. So what is hook? Before hook, the developers was written code in a class-based component, and the state logic and database changes were tightly coupled. That means for any changes of reactive data, sometimes we may need to create a component. And sometimes it becomes a nested tree and it becomes so complex to manage the state. And for this reason, many developers disliked React. Good news is, hook changed everything by changing the access to lower-level features of React, outside of the context of a component. When you use hook, you can pick of them, like a building blocks. Remember that the hook itself is a function, which always starts with use keyword. So let's start. The number 1. useState. useState is the most important hook that we use very frequently in our project. It imports directly from the React library, at the top of the component. The purpose of useState is to handle reactive data. Generally, any data that changes the application is called state. When the state changes in the component, React instantly updates the UI, so the latest changes are reflected to the end user. The useState hook, it takes one optional value in the first argument, which is the state default value. The function returns an array that contains two values to use in your component. The first value is the reactive data that we will use in our component. And the second value is called setter, so that the user can assign the value. If we then reference a set in the UI, and the value changes in the future, React will automatically rebuild the UI to show the latest value. For example, if we introduce a method on click, in this case we can use the setter to increment the value. But look, if we wanted to use the class-based component, then you can see this is far more complex. We need a class to extend the React component, then a constructor to initialize the state, and also notice how the state is referenced all over the request. You can declare the useState setter with two ways. Set keyword in the first place and then the variable name, or the variable name in the first place then the set keyword. Now we will explain another hook, useEffect. useEffect. To understand useEffect, you need to understand how the life cycle of components actually works. Here is the class component, and those life cycles are used to handle the different life cycle methods. Those are the simple breakdown of the life cycle. The component happens for the initialization of the UI, and it happens in one time. Then reactive data of the component is changed or updated. It can happen multiple times. Then finally at some point, when the component will be removed from the UI or unmounted, this component will unmount is called. After that, when React was introduced the hook, the three lifecycle method compact in one hook, and that is useEffect. useEffect is a function which takes two arguments. The first argument is your define method, and the second argument is optional. With the current implementation, it will run the function any time when the state will changes. So that means when the initial state is set on starting of the component, the useEffect method will run automatically. The second argument is called dependencies. If we keep it empty, in that case, there are no dependencies. This means it will run only when the component will initialize. If you give any state name in this third bracket, in this case, it will run when the state change. Now the last thing we want to useEffect, when the component is destroyed. To do this, we use a toDown function, to return a function from our useEffect callback. Now, let's go to the next hook, useContext. There is a frequently asked question that, how you can store a user in the context, and share it throughout your application. So, this is the task condition useContext can solve the problem. This is a mechanism to share data in the child components without passing props. To understand this, in this example I have two pages, home pages and another one is about pages, and you can toggle back and forth between them. So, I want to able to grid the user or who the current user, in the both home page and the about page. First thing that I want to do is create a context to share between my components. Now, I am going to wrap the components in a context provider, and I can pass some kind of value so that the child component can use this. Now any child component inside this can access this value, without the need to pass any props to the children. And it allows us to consume the current value from the context provider, which may be many levels higher in a component tree. Now the value changes through the parent provider will update automatically. Now we will learn another complex hook, useReducer. useReducer is an alternative or very similar to useState. Instead of updating the state directly, you will create a dispatch action, and it will go to a reducer function. After that, the return value of the reducer function determines what will be the next step. useReducer returns an array with two values. The first value is the state that you can use in the UI, and the second value is the function that dispatch an action. In this example, we have used the dispatch action as an object that takes type increment, decrement, and reset. And with this given type the dispatch method is called. Here we have used a switch statement for the expected output, and returns a new state to the useReducer hook. No, you can think, why we will use that complex thing instead of an easy useState hook. useReducer is usually preferable to useState when you have complex state logic that involves multiple sub-values, or when the next state depends on the previous one. So, when you have multiple components, it will be complex to manage the state. And in this case, useReducer plays a great role. Now we will talk about another hook, which is useRef. useRef hook is a function that returns a mutable ref object, whose current property is initialized to the passed argument. useRef hook is very similar to setState, but in the useState hook, the component tree render when the state is updated. The difference is when the useRef value change, it doesn't re-render the component. useRef returns one object, and the returned object will persist for the full lifetime of the component. useRef is mainly used to reference of elements in HTML with a ref attribute. For example, if we create a counter button with useRef, we can reference the current count by calling countCurrent. In this case, if we click the button, the count will never change, because useRef doesn't trigger the re-render as setState does, but the common use of useRef is to grab HTML elements from the DOM. We can start by creating an reference called value, and use it in the input with ref attribute. And now with the button click, reference the HTML input and can use the focus method, which is focus on an input box on click a button with programmatically. Now we will move on to another next hook, useMemo. useMemo is a React hook that memorizes the output of a function. It accepts two arguments like the useEffect hook. One parameter is a function, and another parameter is a list of dependencies. It will call the function and return its return value. Then, every time you call useMemo again, it will first check if any dependencies have changed or not. If not, it will return the cached value instead of calling the function. But if they have changed, useMemo will call the provided function again, and repeat the process. I think you are thinking about the difference between useEffect and useMemo, because both of them are using the same parameter. The answer is useEffect is intended for side effects, while functions in useMemo are supposed to be pure and with no side effects. You should use the useMemo only as needed for expensive calculations. Let's think of an example of counter. Here we can compute an additional property. After that, I have called expensive count. That requires an expensive computation. Instead of recomputing every render, we can memorize the output value. We can write a function that returns a computed value. In the second argument, we had a dependencies, which determines the computation should be run. It will call the method again if I change the count. But if I not change, it will not recompute and it will get the cache value. Now we will move on to useCallback. useCallback is a React hook that is the same structure like useMemo. It also takes two arguments, one is function and another is dependencies, and it is also used to memorize. But the difference between useMemo and useCallback is, useMemo will remember the returned value from your function, but useCallback will remember your actual function. If we look at the example, in this example the output of the function is 10. And as we have used the useMemo hook, it will memorize the return value 10. But in the same example, if we use the hook useCallback, the output of this function is also 10. But in this case, it will remember the whole function. Now you are thinking, that why do we need to remember a function? When we define a function in a component, the function object will re-render each time on component re-render. Usually, this is not a big deal for performance, but sometimes you may need to not re-render the function each time. The common use case is when we pass the same function down to multiple child components. We can use the useCallback by wrapping the function and can give the dependency. Now let's move on to another hook, useImperativeHandle. To understand the useImperativeHandle, you need to first understand the work of function forwardRef. So what is forwardRef? In simple word, forwardRef is a method that allows parent components to pass down refs to their children. Let's see an example. This is a parent component, and this is a child component. We have an increment button in the child component, and that can increase the value. Now, we want to add another button in the parent component to reset the counter value in the child component. To do this, we can take a useRef and the value that can be a reference with the child component. But in the current scenario, ref.current.increment will not work, because this is a functional component, and we don't have any way to access this increment method. To solve the problem, we can use the forwardRef method, and wrap the child component with the parameter, props and ref. In this picture, useImperativeHandle hook will come with the ref, and with the callback function. In this case, we will use the increment method, so that we can use the method from the parent component. useImperativeHandle hook is a rarely used hook, which used to customizes the instance value, which is exposed to parent components when using ref. Now we will know about the hook, useLayoutEffect. The interesting thing is useLayoutEffect looks the same as useEffect. Because their structure is same, their parameters are the same, and even their behavior is same. The only difference is useEffect runs asynchronously, and after a render is painted to the screen. On the other hand, useLayoutEffect runs synchronously, after a render but before the screen is updated. An easy way, if we consider a text showing in a screen, then you can think of the useLayoutEffect call immediately, before the text showing in the screen, and useEffect call immediately, after the text showing in the screen. You may need a situation where you may need to calculate the scroll position, or something you need to calculate before showing in the UI. In this case you can use the useLayoutEffect hook. Now let's understand the last one, useDebugValue. To understand the useDebugValue hook, first you need to create a custom hook. For example, we have a username, and we are currently showing the name in the home component. But the username may need to show in all the components in this project. So in this case, instead of copy the same code, we can make a function. Use displayName, and the only change is the return the username in this method, and call the method from your home component and also in the other component, so that all components can use the same method. Now, if we use the useDebugValue in our custom hook with the argument, the value passed to the hook will be shown in the React development tool. You can see this is the username that we have passed through that hook. If the video helps you to understand the hooks, please like, share and comment.